Good morning, my dear students. My name is Neer Twaina. I am currently available at the Hamlet Tuition Center and Kumudini Kunja Secondary School, Kalimati, Kathmandu. Well, my dear students of grade 10, this is your science class. Today we are going to we have been discussing on the lesson electricity and magnetism, which is your last lesson on physics. Yes, okay. And within the lesson electricity and magnetism, we have been discussing the effects of current electricity. Yes, first we discussed about heating effect, then we discussed about lighting effect, and today we are going to discuss about magnetic effect of current electricity. Well, just like heating effect means conversion of electrical energy into heat energy, and lighting effect means conversion of electrical energy into light energy, magnetic effect means conversion of electrical energy into magnetic energy. Okay, and while we were in grade 9, I also told you that magnetic energy and electrical energy both are the property of electrons. Okay, magnetic energy or magnetic field is created by spinning of electrons, whereas electric field is created by flow of electrons. Okay, and that's why to produce any of them we need another one. Okay, to produce magnetic effect you need electricity, or to produce electric effect you need magnet. Okay, now let's understand this. In a conductor wire, in any conductor wire, okay, if electrons are flowing, that means if current electricity is flowing in any conductor wire, then at each point of conductor wire a circular magnetic field is created. I'm saying at each point. Okay, in this diagram I am showing only one magnetic field at only one point. Yes, but there are uncountable of such magnetic fields at every point of the conductor wire. Okay, so since this is magnetic field, you can simply copy it like this. See, it will create a cloud of magnet. Okay, it will be something like this. Yes, because every point of the conductor will have its own magnetic field. Got it? Every point of the conductor wire will have its own magnetic field when electrons are flowing through it. Remember, only when electrons are flowing through it. Okay, when electrons stop flowing, then magnetic field will disappear on their own. Yes, so remember, only when electrons are flowing through a conductor wire there is circular magnetic field in every single point of the conductor wire. Okay, and the direction of circular magnetic field could be either anti-clockwise. Okay, anti-clockwise means the opposite of clock. Okay, opposite of clock. Clock rotates this way, yes, but this is the opposite of rotation of clock, anti-clockwise, or it could be clockwise. And in this figure, according to this diagram, you can say that this is anti-clockwise direction, isn't it? This is anti-clockwise magnetic field. Now, in which direction does magnetic field rotate or will be produced? That is given by Oersted, a scientist named Oersted. Okay, Oersted, Oersted's right hand thumb rule. If you hold your hand like this in this position, then imagine that you are holding the conductor wire, then the thumb indicates direction of current and rest of your finger indicates direction of what? Okay, magnetic field. See, when the thumb is pointed upward, rest of the fingers are pointed to the anti-clockwise direction. Okay, now what if you invert your hand? What if current is flowing in downward direction. When current is flowing in downward direction, see, the rest of the fingers show you the clockwise position, isn't it? So when electrons are flowing in upward direction, magnetic field runs through anti-clockwise direction, and when electrons are flowing in downward direction, then magnetic field runs through clockwise direction. Understood? Okay. This is the case of straight rod or straight conductor. Okay. However, when we convert that straight conductor into a solenoid like this, solenoid, a coil, yes, a continuous coil. Okay, this is called a solenoid. When you convert a straight wire into a solenoid, then what you should know is each and every point of solenoid contains its own magnetic field. Each and every point, okay, each and every point of solenoid contains its own magnetic field. And since these magnetic fields are very much close to each other, they interact with each other. Okay, the magnetic field of each and every point interact with each other to give a continuous magnetic field, which looks like this. Okay, so here in this case, this point would be south pole, okay, and this end would be north pole. Yes, this end would be south pole and this end would be north pole. That means since this solenoid has developed magnetic properties, it has developed magnetic field. Are you getting me? Since it has developed magnetic field, if you keep a soft iron core, soft iron means pure iron, okay, if you keep soft iron core within this solenoid, then that iron itself becomes a magnet. Okay, got it? And that iron remains a magnet only until current is flowing. Once the current is switched off, then it will lose its magnetic properties. Okay, so that kind of magnet is called electromagnet. See, when current electricity is passed through a solenoid, a magnetic field is induced in the solenoid and the soft core kept inside the solenoid becomes a magnet. It is called electromagnet. Any confusion up here? Now you can make your own electromagnet at your home. Okay, here is how it is shown. This is a battery or a dry cell. Okay, this is a iron nail. Yes, then you take an insulated copper wire. Okay, I said insulated, do not take naked wire. If you take naked wire, then there would be short circuit. Okay, if you take naked wire, then it will act as a single path for electricity. Okay, whereas electrons should flow in a circular path like this. Okay, so you must use what did I say? Yes, insulated. You must use insulated copper wire, then turn it around the iron nail several times, at least 50 times. Okay, more is better. You can wind it up 100 times or even 150 times, 200 times. Okay, as much as you can. Just turn it around. Okay, wind it up around the iron nail. Yes, then one of the wire is connected to negative pole terminal of battery and another wire is connected to positive terminal of battery. Okay, use paper tape, okay, to fix it. If you simply hold it with your thumb like this without using paper tape, then the battery will heat up very fast and you will feel the burning. Okay, you will feel the burning sensation in your hand. That's why it is suggested that use a paper tape use a paper tape to hold the wire, okay, and then after you can hold it with your thumb as well. Okay, so here it shows the result. After connecting it to the battery, you can see the nail is holding an iron object. कहिले उल्टो भएछ यो ओके एनीवे यस्तो हुनुपर्ने है ओके ल जब यो ब्याट्रीमा कनेक्ट गरिएको छ के भइरहेको छ यो नेलले आइरन अब्जेक्ट पेपर क्लिपलाई अट्र्याक्ट गरेको छ है तर एज सुन एज यहाँबाट यो लिंक छुटाइन्छ यो लिंक छुटाउने बित्तिकै के हुन्छ न यो पेपर क्लिप तल चढ्छ गरेर हेर्नु है त दैट इज योर असाइनमेन्ट फर टुडे आजको असाइनमेन्ट तिम्रो प्र्याक्टिकल हो के गर्नु पर्यो त यस्तो एउटा इलेक्ट्रोम्याग्नेट बनाउनु पर्यो कसरी बनाउने तिमीहरूले बुझ्यौ है एउटा फलामको किल्ला लिने त्यो फलामको किल्ला लिने अनि त्यसपछि इन्सुलेटेड वायर लिने है घरमा जुन तार छ त्यही युज गरे पनि हुन्छ तर घरमा भएको तार युज गर्दाखेरि त्यसमा भएको प्लास्टिक या रबरको खोल चाहिँ निकाल्ने होइन है अदरवाइज तिमीले यस्तो मार्केटमा इन्सुलेटेड कपर वायर नै पनि किन्न पाउँछौ त्यो पनि युज गर्दा हुन्छ ओके तर एक्सपेरिमेन्टको लागि किन पैसा खर्च गर्छु है घरमा भएकै मटेरियल युज गर्नु ओके अनि त्यसपछि त्यो वायरलाई चाहिँ किलाको वरिपरि एटलिस्ट 50 टाइम्स बेर्नु है राउन्ड राउन्ड गरेर बेर्नु अनि एउटा एन्ड वायरको एउटा एन्ड ब्याट्रीको माइनसमा ल्याएर टाँस्नु अर्को एन्ड ब्याट्रीको प्लसमा ल्याएर टाँस्नु ओके एन्ड देन अनि यस्तो आइरनको सानो सानो अब्जेक्टहरु यो सानो थम्ब पिन हुन सक्छ हैन स्ट्यापलर पिन हुन सक्छ है अनि पेपर क्लिप हुन सक्छ यस्तोमा एकचोटी अट्र्याक्ट गराएर हेर्नु चेक गर्नु okay that is your assignment if it is possible take the video of your assignment while making it take the video of making it and testing it then you can upload in YouTube or you can upload the video as the reply or comment to this video as well or you can send that video to me in messenger also okay that is how you make an electromagnet yes now next title is construction of electric bell okay you know electric bell means a bell which is operated by using electricity when you switch it on it starts to ring like trrrr. It doesn't ring like ding it rings like trrrr. Okay that trrrr sound it sounds like on off isn't it as it only been on then it will sound like ting but it is in the pattern of on off Tirr. If you slow it down it will be something like ting 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 like that okay well how is it constructed and how does it work okay let us see once okay this is the actual picture of an electric bell with its casing but what is inside is something like this let's see this circular structure is called gong it is made up of metal like this yes it looks like a kachora okay this is called gong yes and here okay shall I write okay this is what gong and here you have somewhat a ball like structure which is called hammer okay this is called hammer and hammer is this part is hammer yes and hammer it is attached to a structure which is called armature okay armature this is armature where to show okay so small space yes okay armature this is armature okay this is armature this whole structure is armature so I'll show it here okay this whole structure is armature and the armature is connected to a pin here you have a pin got it or not see This is gong, this is hammer. Hammer is connected to armature. Okay, armature is made up of spring, it has spring attached in it. Okay, so it is flexible so that the hammer can come down and go up. Okay, the armature, next to the armature is the pin. Okay, and then next structure is this. What is this? This is soft iron core. Soft iron core which is in U shape. Okay, and rest of the structure is wire. Okay, so you can say the wire which is wound up around the soft iron core is solenoid. Okay, the wire which is wound up around the soft iron core is solenoid. Yes, okay, this much is a part of the electric bell. Look at it once. Okay, now how does it operate? How does it produce sound? Let us discuss that in detail. See the picture. Okay, look here, this is battery. Yes, battery has plus terminal and minus terminal. Okay, here is switch. When the switch is off, the whole structure will not operate, because when switch is off, then the circuit will be open one, and you know, in open circuit electricity will not flow and load will not do any work. Yes, now when the switch is on, what you can see here, just find out the path of electricity. Okay, the electricity will flow from here, from plus to here, this wire. Okay, this wire, and then after it moves to the pin, isn't it? From the pin is connected to armature. The pin is connected to armature. Then the armature is connected to the wire. Yes, and this wire moves around the U-shaped core. Yes, that means it forms a solenoid. So electricity flows through the solenoid. Yes, and after coming out of solenoid, it again moves through the switch and to the battery. Okay, so in this way electric circuit is completed. Okay, so when electric circuit is completed, or when electrons are flowing through this circuit, you know that what we just studied, this solenoid will become an electromagnet. Okay, this solenoid will develop magnetic field, and since the soft core is placed inside the solenoid, the soft core also becomes a magnet. Understood? When the circuit is completed, the soft core becomes a magnet, and since armature is made up of iron, the magnetic soft core attracts it. It is fixed over here. Okay, it rotates like this, it attracts it, and when it is coming down, you see the hammer bangs it. When it is attracted downward by the magnet, the hammer bangs the gong. It gives you single tone, ting, like that. Yes, so what you can also see, that as soon as the armature moves downward due to attraction by this core, magnetic core, you see the connection is broken here, isn't it? The connection is broken here, so the electricity will not flow through this circuit. The electricity will not flow through this circuit because the circuit is broken. Now it is open circuit. Okay, so when it is broken, electricity does not flow, and when electricity does not flow, this core does not retain its magnetic properties. The core is no longer a magnet. That means it will no longer attract the armature, and because of the spring system, the armature will go back to its own position. Understood? it will go back to its own position. Got it? Understood? Now when it goes back to its own position, then the pin and armature once again makes contact. Yes, and because of that, once again electricity will start to flow. Okay, electricity will once again starts to flow. Okay, that means it will become a magnet once again, and it will once again attract the armature. Yes, okay, it will once again attract the armature, and it will once again move it like this. Yes, okay, so when it is moving like this, it will hit the gong. Okay, so as soon as the link is broken here, once again circuit becomes open. Okay, and electricity does not flow, it will lose its magnetism and it will go back to its original position. Got it? So this is how an electric bell works. Okay, once again let's see. So it will be something like this. Okay, electricity on comes down. Yes, electricity off goes up, isn't it? Like this. Electricity on comes down. And when it comes down, it hits the gong. And then a circuit is broken, it no longer becomes a magnet, it goes off. Again it comes in contact with the pin, circuit is completed, it again becomes magnet and it again rotates. It attracts the armature. Yes, and when it comes down, the hammer hits the gong, again sound comes. So it will be in slow, it will like ting 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 ting. It's moving. Okay, something like that. Yes, ting ting ting, pale daile घन्टी बजाए ting ting ting. हैन त मिल्यो मैले भनेको, मैले गाएको मिल्यो? ओके, एनीवे तिमीहरुले बुझ्यो है यसले कसरी काम गर्छ भनेर. सो यसमा मेन वर्किङ मेकानिजम भनेको नै के हो त? यो इलेक्ट्रोम्याग्नेट हो. इलेक्ट्रोम्याग्नेट इज द वर्किङ mechanism or working body of an electric bell. It is the load, not this. It seems like gong is the load. Yes, it seems like gong is doing the work, but actually here electric work is performed by the electromagnet. Understood? Okay, now you need to list out some other applications or utilities of electromagnet. Okay, application of electromagnets. Okay, in what fields are electromagnets used? What fields, what applications do you know about electromagnet? Well, as far as I know, all sound producing device, yes, sound producing device means such as microphone, speaker, amplifier, etc. All of them are sound producing devices. All sound producing devices have electromagnets. Okay, electromagnets are used in all sound producing devices, and similarly it is also used in many electronics appliances such as television, radio, etc. Okay, and the next use of electromagnet is, well, it is used to construct an electromagnetic crane. इलेक्ट्रोम्याग्नेटिक क्रेन को बारेमा मैले बताएको थिएँ, याद छ कि छैन? याद छ है? ओके, इलेक्ट्रोम्याग्नेटिक क्रेन इमेज हेरौँ ल। हेर न, यस्तो इमेज मैले देखाएको थिएँ कुनै बेलामा, हेर यो के हो त? यो गोलो भनेको इलेक्ट्रोम्याग्नेट हो, यसमा यो वायर छ है, वायरले कनेक्ट गरिएको छ, यो इलेक्ट्रोम्याग्नेट हो। जब यसमा स्विच अन गरिन्छ, स्विच अन गर्दाखेरि इट बिकम्स अ म्याग्नेट, यस, एन्ड देन इट इज एबल टु अट्र्याक्ट दोज आइरन अब्जेक्ट्स टु इट. Okay, so while it is still attracted, you can move it around wherever you need to transport, isn't it? And when you reach the destination, what you do? You put it down and switch off the electricity. It will lose its electric property. It will lose its electric property, and the object is unloaded. Understood? Okay, that is electromagnet. So to make an electromagnet, to make an electromagnetic crane, also you need to use electromagnet. Do you want to see a video of it? Okay, let's see.
Need a professional website? I created one for our startup using Wix. Let me show you how I did it. First, go to wix.com.
आजलाई यति नै गरौँ है ओके ए सरी एउटा पोइन्ट छुटेछ है हामीले भर्खर डिस्कस गरेको के हो त इट इज युज्ड टु कन्स्ट्रक्ट एन इलेक्ट्रिक बेल होला एउटा छुटेछ एनीवे ल यसमा पनि अरु अझै तिमीले केही थप्छौ भने थप्दा पनि हुन्छ है जस्ट find it out whatever devices use an electromagnet okay and then add to the list okay this was for today we'll see you in our next class and in our next class we'll discuss Faraday's electromagnetic induction okay and its application okay that's all for today thank you class